In this lecture, we're going to go over some logistics of the course, as well as overview the topics that will be covered in this course. First off, some basic course information. First of all, I'm the instructor, Gautam Kamath. You can reach me at this email here. I will be holding office hours twice a week on Tuesday and Thursday at noon Waterloo time, or otherwise by appointment. I hope noon should work for many people because it's reachable at both people at Waterloo or on the East Coast, as well as it's a bit early, but people on the West Coast as well. It might be a bit difficult for anyone here who's in China or India, but that's why, or other places as well, yeah, Australia by any chance. But I'm also going to be reachable by appointment. If none of these times work, email me and we can figure something out. We've got a great set of 3 TAs who will be helping out for this course, Lasantha, Yuxiang, and Kamyar. The course website is listed right here. It's on a sub-website of my homepage. And this will contain the slides, notes, assignments, logistics, all the information that you need to know about the course. And if there's anything you're unsure of, just start there and you should be able to find whatever you're looking for. We have a few different platforms we're going to be using in addition to just this website. In particular, I'm going to upload my videos to my YouTube channel. I don't have a link here, but it'll be linked from the website. That'll contain the lecture videos. Now, I'm also wondering, YouTube is very convenient, I know, for many of you, and for me personally, I like to watch videos on YouTube. It's much better than doing it on Learn. But I know, for example, that Learn is inaccessible YouTube is inaccessible in certain countries. So I asked a question on Piazza asking whether you'd prefer I also upload on Learn, but otherwise by default, I'm just going to upload things to YouTube. There is a Piazza for this class. You should have all already been enrolled in it. You can see the link is right here. And there'll be some course announcements made here, which will probably, if they're important announcements, will also be made via email. And then you can also ask questions and I'll try to answer them as quickly as I can. We'll be using Learn and Crowdmark, and this will be for submission and grades. Generally, we're going to have written assignment submissions on Crowdmark, and code will be submitted via Learn. And we're also going to be using Microsoft Teams. This will be used for office hours. In particular, during these stated office hours, Tuesday and Thursday at noon, you can just ping me and I'll take people in a queue in order, first in, first out. Okay, so that's some of the basic info about the course. In current terms of a textbook, this course does not have a required textbook. What I'm going to do is I'm going to link materials or suggested readings from the website, which may actually come from different books or sources online. And the website also links some good reference books. For example, Dive into Deep Learning by Zhang et al. Deep Learning, which is a pretty modern classic reference by good fellow Benjo and Kerville. Understanding Machine Learning by Shai and Shai, Shai Shalev Schwartz and Shai Ben David. The latter are the faculty here at Waterloo. And also The Elements of Statistical Learning by Hasdi, Tibshirani, and Friedman. These are all classic references, and you can learn a lot from these books. So I'll probably be linking these at times for just reference for reading. So the prerequisites. You're in this course. What will you need to know to get the most out of this course? Well, there's the official course prerequisites, which are stated algorithms and statistics. But really, those are for the, of course, you should know these, but this is for just kind of the course catalog. What do I think you need to know to get the most of this course? What you really need to know is the following things here. You need to know math, basically. You don't need to be able to do probability, statistics, linear algebra, calculus, and these are critical to understanding the various parts of machine learning. In particular, deriving many of the things we do, you'll need to remember your calculus. I know this has been a while for some of you. In particular, I think you have to take some of these classes during your first year, and maybe now you're in your 4th year. So maybe you've forgotten it all, hopefully not. I think these are very important things that you need to know throughout your degree as well as throughout your life. But these are things you'll really have to, if you've forgotten, pick them up again and remember them. Don't worry, I'm going to try not to spring them on you in the sense that if there's something that I feel like we haven't seen in this course yet, then I'll try to do a little bit of a background or reminder. But nonetheless, it will be expected that you know these topics. So if anything is too unfamiliar for you, then maybe come talk to me, or maybe it's worth spending a little bit of time brushing up on the type of stuff you learned back in your calculus and linear algebra classes. And of course, since this is machine learning and it's a computer science class, you'll need to program as well. There are pure theory machine learning classes here. For example, Shai Ben David, he teaches one of these classes, but in this class, we're going to have some programming assignments. So you need to be comfortable in programming. We're not going to be doing, in none of these topics here, any of the prerequisites, will we be doing anything super, super fancy or advanced. It's just really the basics. And an important thing you'll need in this class is what's known as mathematical maturity, which is a bit of an arcane phrase. I, to be honest, don't fully know what it means. But it basically, what I intend for it to mean here is that if you see something that looks mathematical and it might not be familiar to you, then you don't just get scared and give up. You try a little bit harder, you think about it, you try to maybe make some simple examples in your head, try to understand what it means, maybe read more, look up more if you don't understand what it means at first, and you try to learn it yourself, being mature in that way. The workload for this class. We're planning to have between 20 and 25 lectures, each about 1 hour. Like, we'll see how it really goes, in the sense that maybe these will be faster lectures because there's no questions, so no one's stopping. Otherwise, maybe because there's no end of class, I might end up going a bit longer. So, but my target in general is going to be 1 hour per lecture. There's going to be between 20 and 25 lectures. I'm still figuring something out. For example, I feel like the spring term is a little bit of a marathon because there's no real break in the middle. There's Canada Day, which gives you a long weekend, but it's not like other terms where you have a full reading week, which I think is very important to take a little bit of a breather and get some, just get your feet in the middle of the term. So I might have an impromptu reading week for us, because I think we'll be able to cover pretty much everything I want anyway, even if we maybe skip a lecture or two. So yeah, somewhere between 20 and 25 lectures. There will be 5 assignments for this class, roughly 1 due every other week. So there's only 5 assignments really, so they're going to be a little bit challenging, maybe a little bit long, but there's only 5 of them, so hopefully you can manage this. The lowest assignment score of these will be dropped. So for example, if times are too tough for one, and you just really have a lot of things going on and you aren't able to do as well as you'd like, well, don't worry, because your lowest assignment score is going to be dropped. So with that drop, there's really 4 assignments which are actually worth something. Each one will be worth 20% of the grade. So 4 times 20% will give you 80% of your final grade. We'll talk about the last 20% in a slide or two. You will submit on, like I said, CrowdMark and Learn for your write-up in code. And I'll just suggest that you should typeset your assignments in LaTeX. LaTeX typesetting is, again, it may or may not be something you've done before, but if not, it's something that I think is very, very important to learn if you ever want to typeset any sort of mathematics. And yeah, now is as good a time as any to learn. If you are unfamiliar with LaTeX and you've never done it before, then let me know and I can link you to some resources. Just ask on Piazza and I can show you some tutorials or something. Policies for this class. One of the important things is that I want you to do your own work. That means if you're working with others, you definitely can have some high-level discussions, talk about things. But what I don't want to see is literally copying or sharing code or solutions. That's bad and against the academic integrity. I'm sure you might know even better than I do all the consequences for academic integrity. I really don't like to have to, for violating academic integrity, that is. I really don't like to have to do anything about it, but just please try to go by the rules and everything will be okay. And in particular, if you use any sources that help you during this class, be sure to mention them. You know, you looked at this site, you found this paper which you thought was useful, you talked to your friend, your cat gave you some inspiration. Just acknowledge whatever you do. In terms of other policies for the homeworks alone, for just the assignments, there will be 2 48-hour extensions for the assignments. Please read the rules on the website. You can only use 1 per assignment, and you have to email us 24 hours in advance. But yeah, just make sure you read the rules. And this is a new thing I'm trying out, which I think I'm being a little bit more generous than sometimes in the past. So please use these if you need them, because I know things are tough right now. If you need further extensions, we're not generally going to consider them unless there's like something serious going on, for example, some sort of illness, and you'll need documentation. But the two 48-hour extensions for assignments, though, they're kind of no questions asked. You can just use them whenever you want. In terms of regrade requests, we're going to ask that you request a regrade within 1 week of grades being released. And we'll try to get the grades. We'll try to get the grades to you within a week of submission. We'll see how things go, but that's kind of the target. Oh yeah, there's one thing I forgot to mention, I guess, here in terms of the lectures. When will the lectures come out? So the sort of intended course times to watch these will be ideally sort of Tuesday and Thursday during the morning. Like my goal is to try to upload them by, say, late on Monday and Wednesday, and then you watch them on Tuesday and Thursday during the morning. I'm not perfect, so I wouldn't be surprised if I slip a couple times, but really by the end of Tuesday or Thursday it's almost for sure they'll be up if the videos are coming. So yeah, the goal though is to try to have them up on the night before so that you'll be able to watch them on Tuesday and Thursday morning. Cool. Let's see what else. Okay, yeah, so those are the policies. In terms of the final project, so there'll be a different, the assignments count for 80% of the course mark. The final project will account for the last 20%. And it's going to differ depending on which version of the course you're in. If you're in the undergrad version of the course, CS 480, there will be a Kaggle competition. A Kaggle competition is basically kind of just a machine learning competition. There's going to be some data set given to you, some training data set and some task. And basically you're going to have to try to make an algorithm which does well on this data set, on this task. And so there's going to be a test data set given to you, and you have to sort of predict the labels for these items. So that's for CS 480. There should be more information coming out in maybe a week or two. Hopefully, I plan to get this up relatively early in the course. This will be due, or the competition will close at the very end of the term, kind of during exam week. Now, as for CS 680, the graduate version of the course, my expectations are somewhat higher. For this, I want you to do a research project of some sort. And the ideal, what I picture, like the perfect 10 out of 10, 100% project would be a novel and interesting project which is submittable to an ML conference, like really something very impressive. That's kind of like my ideal. I know that, you know, this is a very high bar, so it probably won't happen for many of you. Maybe some of you would feel inspired by this, but really, I just want something which is novel and interesting, and hopefully you learn something and show something cool. There's two things. There's a project proposal, which is 2 to 4 pages, worth 5%. This will be due sometime in the middle of the term. And there'll be a report at the end of the term, due the same day as the Kaggle competition, which you don't have to do both, but depending on which version of the course you're in, you do one. But the report will be due on the same day, and that's worth the other 15% of the final course mark, so 75% of the assignment of the project. And in the middle there'll be a check-in with your TA who will be assigned to you, which will not be graded, but it's something where you're expected to do. So there's more information on both of these on the course website. The Kaggle competition will have more details coming in a little bit as we set it up. So okay, that's enough about logistics. Now let's talk more about what is this class, what is machine learning, and why should I care? I know I'm covering up the top right, but why should I care? So what is machine learning? Machine learning, it says, given data, learn something about it. Well, this is super general, and it's kind of a tautology. Learn something about it, of course, that's what machine learning does. But that's because machine learning encompasses a lot of different things. It can mean many different things depending on which different task. My 2 cents is that it's kind of a fancy way of saying statistics. It's just, I don't know, sells better. And I guess there's slightly different semantic meanings in terms of what type of problems we consider machine learning. But honestly, it's a pretty wide umbrella, and you can use it for a lot of different settings. But one thing that machine learning says is, imagine you have some data, you want to find some structure that exists in the data. For example, maybe you have all the data lies in one cluster over here, and all the rest of the data lies in one cluster over here. And so maybe you need to find that, okay, we notice that there's some points which are clumped together and some points which are clumped together. So we want to find clusters. This is called clustering. That's a classic machine learning problem. Another thing we might want to do is find something and learn something about the distribution that generated the data. So this is when we're dealing with a setting where we imagine our data set came from some distribution, and we want to figure out something about the underlying distribution. For example, a survey is kind of like when we gather data, in the sense that we have some population of humans, but we take a small sample, and we want to understand something about the whole population which we sampled from. That's kind of what another sense in which we might say machine learning. And another thing is trying to figure out the relationship between features and labels of data points. So this is kind of what you picture with classification. What type of features result in something being, so if you have a picture, which is, say, has a bunch of different pixels, what set of pixels will you need? Make it so that it looks like a dog, or it looks like a cat, or something like that. So that's another thing that we can say machine learning is. So machine learning is pretty general in terms of what we can call machine learning. So I wouldn't stress it too much about trying to figure out what is and what isn't machine learning. But it's really everywhere. It's ubiquitous. For example, Gmail, Netflix, Facebook, Apple, Amazon, all of these companies use machine learning. And this is just like a very non-exhaustive list. Pretty much anything that uses data in any way, any company that uses data in any way, or any product that uses data, it uses some form of machine learning with pretty high probability nowadays. Just to give you some examples, for example, Gmail. You might have seen in Gmail, there's suggestions on next words. So you start typing, hey, how are, and it might suggest the rest of that sentence is you doing, things like that. That's using machine learning. Similarly, Netflix has a recommendation engine which uses machine learning, where if you've watched one movie and you've watched another movie, for example, you watch Die Hard 1, Die Hard 2, then maybe it'll recommend to you Die Hard 3, just for example. Facebook has recommendations in terms of friends. If you're friends with one person, another person, and they both have a common friend, maybe that's a good person to suggest as a friend. Apple uses machine learning in Siri, and so on. It's really everywhere. And personally, I consider machine learning an essential topic for a student of computer science. I think at this point, if you're doing a computer science degree, you can't really afford to be ignorant about machine learning, just because it's a very big thing right now, and I can only see it growing bigger in the coming years. So you're just starting your career in computer science now, so you really don't want to be left in the dark and have to pick it up some later time. And let's talk a little bit more about different types of tasks which we might do. There's very roughly speaking, 3 different types of tasks, types of problem that you might do in machine learning: supervised learning, reinforcement learning, and unsupervised learning. Of course, there's other things which may fit on multiple of these, or things that fall outside of all these domains, but roughly speaking, I just want to give you a sample of some of the tasks you might consider. So first off is supervised learning, which is perhaps what many of you think of when you think of machine learning, which is, say, things like classification. For example, I have this picture here. You see this picture and you know this is a cat. Well, it turns out we can also train machine learning models to be able to make that exact same inference, which you just did with your eyes and your brain. Similarly, things like regression, finding the relationship between one continuous variable and another. Say, like, for example, just to give you one example, suppose you have the feature, which is the square footage of a house, and you want to be able to predict what the price of the house will be based on the square footage. So you can imagine that there's some sort of relationship here, maybe a linear one, maybe a quadratic one, who knows. But the idea is that regression often tries to say, okay, if you have a certain square footage, for example, can we predict what the price of the house will be? And also ranking problems could be considered supervised learning. That's one type of learning. Another type of learning is reinforcement learning. Reinforcement learning is pretty popular nowadays in settings which we want to do, say, control, say, like robotics, or especially games, I think, are some of the flashier applications of reinforcement learning. For example, you can see here at the bottom right where AlphaStar, which is an AI by DeepMind, this uses reinforcement learning to be able to play StarCraft 2 at a competitive level at, say, around the level of top human players. or at least grandmaster level players is what they're saying, which is kind of the best of the online players. Mana here that's playing against was a pro StarCraft 2 gamer for many years. And yeah, I think Alpha Star beat him maybe 2-1 or something. I can't remember. So this is incredible level performance. People train for years to become as good as this, and it seems like this Alpha Star AI can play competitively. Another thing is the game Go. Go is a classic board game, which you can see here, the picture of it on the left, and a very high-profile success of reinforcement learning was being able to beat the top players of Go. This is an impressive feat because we already knew that computers could beat humans at games. For example, chess. Chess very famously, Deep Blue beat Kasparov several years ago, maybe before even some of you were born, I think. But the thing is, chess is comparatively very easy compared to Go. Go is a very challenging game with a very high, what's known as a branching factor, and it was thought that the best human players would outperform the best computer players for many years. This was seen as one of the hardest board games for computers to beat humans at. But very surprisingly, I think in 2015, computers just comparatively easily beat the best human players. So that was a rather surprising turn of events. So reinforcement learning is popular in some things like this, but I'd say it's a relatively perhaps more advanced topic, or at least we're not going to get into it in this class. There's other classes which focus more on reinforcement learning though, and you should check them out if you're interested. And finally, unsupervised learning, which contains essentially the way I would roughly break it down is supervised learning happens when you can label things, like things have, for example, there's a cat, there's a dog, and so on. Unsupervised learning kind of comes when you don't have labels or you don't use labels. For example, the thing I said earlier where clustering, you have some points over here and some points over here. Well, you want to find that there's some clusters here, and that doesn't depend anything on the label of the point or any sort of metadata. It only depends where the point is, things like that. So clustering, visualization, learning representations, density estimation, these are the sorts of things that unsupervised learning can do. And it's been a really exciting area recently because of just some of the honestly amazing things that unsupervised learning can do. For example, take a look at the left. This is at the picture on the left. This is, I think, from GPT-3, I believe, maybe 2, I think 3. Either way, whichever one it is, you can see what's going on here. At the top, there is a human written prompt, which is just a sentence or two sentences. And based on this 2-sentence prompt, you can see that the AI, the machine learning system, it was able to generate this entire article here, which is a bit odd, talking about unicorns and where they lived in the Andes Mountains and stuff. It's kind of a bit odd of a news story, but it's a real, it looks like a real news story in the sense that it's coherent, the sentences link to each other, there's a lot of memory in terms of previous things being referred to later on. Yeah, it just, you could imagine a human might have written something like this, if not for the subject matter. So it's just surprising to me, at least, and a lot of people, that this works so well. Another thing on the right, you might be surprised that why did I just put a picture of a random person? Well, the reason is that this person, despite looking pretty realistic, this person doesn't exist. And you can see this website here, thispersondoesnotexist.com. Just go there and you'll find a bunch of pictures of people who do not exist. And what's going on here? Well, this is an image generated by something known as a GAN. So what a GAN does, it tries to learn a distribution in the sense that what you do is, what you can do for the particular GAN that this is an output of, is you just feed in a whole bunch of images of people's faces and pictures, and you show it, this is what a human looks like, this is what a human looks like. And from there, it learns, what does a human look like? And so then it can spit out new people who look like humans. And they're surprisingly good nowadays. So yeah, just take a look at this person. He seems pretty realistic, pretty reasonable person. I intentionally picked one which is not quite perfect because sometimes you can see these little artifacts. For example, take a look at the glasses. You can see it's a little bit warped here and you can't really see his eye. I don't know, it's unclear what's going on there. So it's a little bit not imperfect, but there's other ones which are much better. And also, this is from a paper which is like maybe 2 or 3 years old now. I think I think this uses StyleGAN, which is from maybe 2018, which is in machine learning time, ancient history by this point. But you can see that this is a surprisingly good looking base in terms of realisticness. Yeah, so there's been a lot of great successes in unsupervised learning as well. So what are we going to be covering within this course? Well, we're going to be covering sort of maybe 3 or 4 different phases. The first phase will be classic machine learning. These are the things that you have to know and you have to understand. These are the things that we understand reasonably well at this point in terms of where they work and where they don't work and stuff like that. So this will include methods which are classic, things from up to say 50 years ago or something. Things like perceptron, linear regression, k-nearest neighbors, logistic regression, support vector machines or SVMs, kernel methods, decision trees boosting. These are the things that every machine learning person should know. We'll then move on to neural networks, which are a little bit more modern. Things like MLPs, deep networks, then CNNs, recurrent RNNs, GNNs, various optimizers, which are commonly used in these settings, stuff like that. We'll talk also about generative models, mixture models, GANs, VAEs, which are variational autoencoders. And then toward the end of the class, we're going to close up by talking about some maybe more modern topics in neural networks. For example, things like attention, which is a very popular thing, especially in large language models nowadays. Other concerns, things like robustness, how machine learning models are brittle, data privacy in neural networks, as well as fairness and ethics in machine learning. So yeah, hopefully, I think this is going to be a fun term. There's going to be a lot of really cool things we're going to cover. And yeah, I hope you're looking forward to it as much as I am.